solve the LPP by using DPP. So maximum Z equal to 2x1 plus 5x2, and subject to constraints. Subject to constraints are given as 2x1 plus x2 less than equal to 430, and 2x2 less than equal to 460. x1 x2 x1 x2 greater than equal to 0. So this is our problem. So try to solve this problem on the Meenakshi. So when we solve this problem, that means first we check how many variables are there we use in the problem. So there are two variables. So we write as the given problem, since there are two variables used in the problem, two variables used in the problem, then the problem are two-stage problem. Basically, stage depends here on the variables. So we cover this problem into two stages. So there are two-stage problem. We proceed as backward computation procedure. Proceed as backward computation procedure. So backward computation procedure, that means same previous problem we also solved by using this method, backward computation procedure. So function we write as f1. So that means f2, because it has two variables, f2 function f2. So x1 x2, this equal to, we solve for x1. Here we find out the x1. So x1 first constraint contain only x1. So when first constraint contain only x1, so write the value of x1. That means maximum of x1. What is the value of x1? That means when we put x2 equal to 0, so gives us 215. So we write as the x1 lie between 0 to 215. We see the second constraint, but second constraint doesn't contain x1 variable. So when it doesn't contain x1 variable, so this means that we don't take the value of x1. So only we have one value which is lie between 0 to 215. Now we write the objective function maximum. That means we have to determine the maximum value, so which is 2x1 plus 5x2. So this is our main problem. Now we put the value of x2. Put the value of x2. So we put the value of x2. Then we write as maximum of x1 lie between 0 to 215 into twice of x1 plus 5. We calculate the value of x2. That means we consider a minimum of x2. What is the value of x2 from first constraint? The value of x2 we write as 430 minus 2x1. So this is 430 minus 2x1. 430 minus 2x1, and what is the value from second constraint? That means the value of x2. So you divide by 2, 4 to 60. That means this is 230. So here the value of x2 is 230. So this is our value of x2. That means we constrain from constraint first and constraint second. So this is equation number 1. This is the equation number 1. Now we solve this for minimum. Which value we consider as minimum value of x2? So that means now we take minimum value at same value of x1. That means which is lie between 0 to 215, and the function having value 430 minus 2x1 comma 230. So we check the value, which value in both are minimum when x1 lie between 0 to 215. So obviously second value is constant, that is 230, but we see that when we substitute the value of x1 as 0, 1, 2, 3 up to 250 gives 0. So obviously minimum value we can obtain from first value. So this means we can say that the first value is minimum. So we write as 430 minus 2x1. 430 minus 2x1. This is the minimum value at x1 lie between 0 to 250. 15. So this is the minimum value. Now when we obtain the minimum value, so then we substitute the value in equation number 1. So we eliminate this minimum word. So we write as 5 into 430 minus 2x1. So we write as from equation number 1, f2 x1 x2 equal to maximum of 2x1 plus 5 into minimum value. Minimum value is 430 minus 2x1 if x1 lie between 0 to 215. This gives us minimum. So now when we obtain the minimum value, so then now we obtain maximum value. So what is the maximum value? What is the maximum value of the function? So, with lie, that means x1 lie between 0 to 215. So maximum value. So just we try that means to obtain the maximum value at because the interval is large means 0 to 215. So 0 to 250 interval is large, so we get the maximum value of the function. So we see that means we try to some rough work. When we do some rough work, that means we obtain the value of function which is maximum. So that means first when we put suppose x1 equal to 215, we put the maximum value. When we check this, that means when we put x1 equal to 215, so then we got the maximum value. So we take this value maximum of 2 into 215 plus 5 into 430 minus 2 into uh, 2 into 215 into 215. So 215 into 2 yeah, 430. So 430 minus 430 0. 434 minus 430 equal to 0. So this means 5 into 0 0. So this equal to 430. So when we put x1 equal to 215, we got 430. So we see that this value is not maximum. Now we check again at x equal to 0. What value at x equal to 0? So gives us 0 plus 5 into 430 minus 0. 430 minus 0. So add this 0. So about that means x equal to 0. This value cannot consider. That means x1, x2, we have two variables. Both are greater than 0. So now we take the ideal values. That means when we put x1 equal to 100, x1 equal to 100. So you see that give the maximum value. Maximum value, what is the maximum value here? So maximum, that means 2 into 100 plus 5 into 430 minus 2 into 100, which is 200 plus 5 into 230. This gives us 200 plus 23 5 115. So this gives us 1350. 1350. When you try put the value of x1 as 90, x1 110, 120, 130, etc. So we give the maximum value. That means so x1 equal to 100, or give the maximum value is 1350. So we obtain the value of x2. Value of x2, which is equal to minimum of. So for finding value of x2, so we have the function this 430 minus 2x1, minimum of 430 minus 2x1 into second value is 230. Second value is 230. 230. So what is the minimum value? That means when we put x1 equal to 100, because we find the value of x1 as 100, so we write as minimum of 430 minus 200 into 230. So this equal to minimum of 230 comma 230. So this means 230. So you remember the value of x2, x2 which is 230, x1 equal to 100, x1 equal to 100, and maximum z equal to 13, 15. So when you want to obtain maximum z by using this object, no issue. So we given as 2x1 plus 5x2. So give the same answer. We find directly. So that means 200 plus 100, 1150. So this means 3. So that means when in long questions, that we question given in this form, solve the DPP. So there are some questions can be asked in this form. That means when we solve this dynamic programming problem, that means any problem which we consider, suppose we consider this problem. So how many variables used in this problem? So you can give the answer. That means there are two variables, two constants are used in this. That means x1, x2, this variable are used in this problem. And uh, how many stages are there to solve this problem? So you can say that means the problem having two variables. So there are two stages of the problem. So same procedure. That means here we write two variable problem, two stage problem. So we write in each question. That means we solve this question also having two variables. This question also having two variables, and so next problem. What is the value of x1? So just you solve this problem. That means value of x1 and what is the value of x2. So what is the value of x2, x1, x2, and maximum z. So question can be asked in this form. So you do practice all the questions. Noted. Meenakshi Manshi. Okay. Now we have one more problem. Try to solve this problem. Second problem given in this form. That means maximum z solve the LPP by using DPP. Maximum z equal to 5x1 plus 10x2 and the subjective constraints 10x1 plus 5x2 and the second 4x1 x1 x2 greater than 0. So this is the next problem. Same similar pattern we have to follow to solve this problem. So try to solve this problem, and one thing you have to remember, you note down the note. Sometime a question can be asked about the resource. So in this form, that means write the value of the resources. Write the value of the resources. Write the value of the resources, which in the form of B1, B2. So what is the answer of this question? What is the resource? When you solve lots of problems in LPB, in optimization technique, and here in advanced optimization techniques. So what is your answer? Mansi, Meenakshi, Ankita, what do you mean by resource? Shifali, Vibha, resources, that means based on the availability. Availability, we make the constraints on the basis of the constraints. That means these are the resources 430 and 460. We bound them. That means we cannot go ahead of this with these values. 2x plus x2 less than equal to 430. That means 430 resources are available, which in the form of the raw material and pieces, etc. So we write the answer, the resources. That means V1 and V2 are 430 to 460. So this is the answer when ask anyone about the resources. Similar, you can write the resources of this. So that means these are three constraints. So resources write in the form V1, V2, V3 because we have used three constraints. Three different materials are used. Here we use two constraints. So the value of V1 and V2, the resources, we write as 21, 21. So remember this, resources now try to solve this problem and tell me about the values of x1 and the maximum z. Solve this problem. You have 5 minutes. Try to solve this problem within 5 minutes. Similar problem, we already solved 3 to 4 problems. No need to write again and again. The problem have two variable, so the problem is two-stage problem, and we write backward computation procedure. This is understood. Every problem having two variables and a two-stage problem, and we use the backward computation procedure. Only one method we use to solve the LPP by using DPP. So just make a function and write the value of x1, x2, and decide which value is f2 of x1, x2 equal to maximum of. So the value of x1 from first constraints, when we put x2 equal to 0, so that means 250, and from second constraint x, the value of x1 0 to 500. Put x2 equal to 0, and we write the objective function 5x1 plus 10x2. Just we calculate the value of x1 from both constraints. Here we put the value of x2. We put the value of x2. So that means we write as so first we decide that we take the value of x1, that the first value we consider or second value we consider. So you decide this, then move further. We solve already various problems related to this. That means here two variable problem, you see that. So we write two values. That means two values of x1. These are two. So the two variables problem two stage proceed backward computation procedure. So this value is greater than to this value. That means gives the greater value. So we use the lesser value x1. So similarly, you see that means x1 in first case lie between 0 to 250, and x1 and second case lie between 0 to 500. So we consider first one. So the value of x1 from 0 to 500 greater than the first value. So we consider this one. Greater than first value which is x1 by between 250. So we consider this value, this one. So we write as x1, x2. We consider this value. That means maximum of x1 lie between 0 to 250, 5 x1 plus 10 x2. What is the value of x2? So value of x2 we can determine from constraint 1 and constraint 2. So we write as 2500 minus 10x1. So when we divide it by 5, so this gives us 500 minus 2x1. 500 minus 2x1. And from second constraints, what is the value of x2? The value of x2 2000 minus 4x1. So this means 2000, 200 minus 4 upon 10. 4 upon 10 is 2 upon 5x1. So this is the value of x2 from second constraint. So we put both values from first and second constraint, gives name of the equation is 1. Now we shall here we write minimum. We write the minimum of. So now we solve for minimum. For minimum of 500 minus 2x1 and 200 minus 2 upon 5x1. At what value? Value of x1 we consider as 250. Value of x1 we consider 250. So we try to find a minimum value. What is the minimum value? When we put x1 0 500, that means 100 200 300, that we put 300 100, so 520 40 160 160. That means second function give the minimum values. Second function give us the minimum values, or we try to put other values. That means 20 x1 equal to 10, so that means 480 10 4 196, that means 250 250 50 100 100 0. 1200. So we check the values of x1, which gives us a minimum. So when we put various values of x1, so for this particularly, so that means when we put x1, which is like between 0 to 250, that means we try to put 100, so that means we have 300, and that means 240, 160. And when we go to 200, so gives us 100, and this gives us 40, 80, 120. So this means second function gives the minimum values in various cases. So we write this equal to 200 minus 2 upon 5 x1, when x1 lies between 250. So we put x1, x2, this equal to maximum of 5x1 plus 10x2. 5x1 plus 10x2. So x2, this means 200 minus 2 upon 5x1. If x1 lies between 0 to 250. Now we find out the maximum value, that means value of x1, which give the maximum. Then the maximum value occur, that is at what value give the function maximum value. So which is, we substitute the various values of x1, so gives us x1 equal to 187.5, and corresponding find the value of x2 and find the value of maximum z. Find the value of maximum z. So maximum z occurs approximately 3652. So these are the values. Use the formula minimum of 500 minus 2x1, 500 minus 2x1, 200 minus. So put these values. That means the value of x1.